Recording computer. Okay, now recording. Okay, so let me restart. So for number one of the Google form, you have two identical automobiles. So let's assume that each weigh 1,000 kilograms. And one's traveling east, say at 40 meters per second, and is going west, so we'll say it's negative 40 meters per second. So east usually tend to go into the right. If you look at a compass, we'll consider the positive direction, so west is opposite. So the answer is no, of the opposite sign, because it is a vector. So their kinetic energies are the same. That is good. Go ahead. Was there a question? Okay. So that's number one of the Google form. Let's keep moving. Number two objects have the same momentum. The velocities of these objects necessarily have the same directions and the same magnitudes. So you could have different masses. Like, for example, let's say mass 1 is 100 kilograms, and V1, let's say, is like 20 meters per second. Then mass 2 could have, of course, 200 kilograms, and V2 would be 10 meters per second. So to have the same momentum, so they don't have to have the same magnitude. So the answer would be not necessarily for B. It could, but definitely have to have the same direction if you want to have the same momentum. So that's going to be yes for sure. So like that, that's good. Momentum is a vector, therefore direction must be the same. They have the same direction. It wouldn't be the same as objects could have. This is a great response. Who wrote that? That is fantastic. This one looks a little wordy. Let's look at this one, but wordy is good. Two ends have the same direction. That by definition, respect velocity must be in the same direction. Good. Good. This is great stuff. This is going to help you as tremendous for the conceptual stuff here. I think what I'll do actually, I think probably I'll publish these and maybe put them up in the updates so you guys can look at this. This is good stuff here. Let's keep moving. And if you haven't submitted, please submit this morning if you can, maybe during a break or whenever you can squeeze that, or after class, that's fine too. I still haven't done inventory of grades yet, so I'm going to try to do that tonight if I can. Can a single object have a kinetic energy but no momentum? And can a system of two or more objects have total kinetic energy that is not zero with total momentum that is zero? So first of all, if you have kinetic energy, you're clearly in motion. So the answer is no. So A should be no. So definitely that one's a no. I see that in the choice, which is great. Can a system of two or more objects have total kinetic energy is not zero? The answer is yes. The reason why, because velocity is squared when calculating kinetic energy. So that's always, so it's never negative. Because mass is not negative either, right? But momentum can be negative. And so you could get total momentum, like one's positive, one's negative. Yeah, so let me look at some other responses here. Good, good. Good stuff. But it's really because of velocity squared. 4, you have a choice. You may get hit head on either by an adult moving slowly on a bicycle or a child that's moving twice as fast on a bicycle. The mass of the child on the bicycle is 1/2 of the ball. was on bicycle, one issue is mass velocity, which collision, it doesn't matter. Good, because you double the mass of one, but you half the velocity of the same thing, so it balances out. So it should not matter. So good job. And then finally, 5. Not sure if any of you guys follow golf, but it's one of the sports that's finally back. So there's actually a big tournament going on this weekend. So when you're driving a golf ball, a good follow through helps increase the distance of the drive. So anyone who's actually hit a golf ball, like if you kind of swing the club and kind of stop in the middle, it's not going to go very far, right? You kind of want to swing it all the way through, and of course make good contact. Using impulse momentum theorem, explain why the stick allows you to hit the ball further. Well, if you think about it, it's really because, let's say you have I'm going to be terrible drawing this. Say he has this golf club right here, right? So right now your initial velocity is probably going to be 0 when you're at the height. I mean, of course you coil it back, but that's when you really kind of start generating the power, is when you're kind of like all the way back. And then you swing through, right? Say the ball's like right there teed up on the ground. We'll just say it's fast. So what's going to happen here is that impulse is going to be the change of momentum from final to initial. So it's the change of momentum, right? And so because also remember, impulse is force times distance, right? So, obviously you're applying some force, but the distance is also going to increase as well. So there seems to be a correlation between VF and D. So that's kind of the reason why what you want to say there. I think it's considered time. I haven't really thought about that. That could probably work too, but a lot of it is also your velocity. Okay, cool. Good stuff though. So now we are going to move on. So let me actually, I'll stop that video.